Well, it's that time again. I guess it's time for more AP Physics 2. We're still in the middle of quantum, atomic, nuclear, whatever physics. This is part B. We're going to talk about labs and activities that are specifically geared toward discussing the photon energy and how photon energy interacts with atoms and things like that. Oh, yeah, you know who I am. Okay, Photoelectric Effect Lab. There are photoelectric effect devices that you can buy. I haven't heard a price lower than $500 for one. So if you buy one, Godspeed, but I would buy one and I would do it as an entire class, like working together type lab. And then you can find some documentation on that. I don't have one of those. So you would use different frequencies or wavelengths of light. You would stimulate some electron emission, probably in the photoelectric effect device. And then you can plot a graph of energy versus frequency. That's really what you need your students to do, is to plot some energy versus frequency graphs, and they need to know that the slope is Planck's constant. So you can use a photoelectric effect lab in real life. There is a photoelectric effect simulation on PhET that you can use, or you could do the Photon Energy Lab that I'm going to show you. So the lab I'm going to show you is called the Photon Energy Lab. It is pretty ornate. Just going to tell you that. Here we go. You need a voltmeter, and you need 2 or 3 batteries, so you're making about 3 to 4 volts. You need a couple of variable resistors. The ones that I used went from 0 to 100 ohms, variable resistors, and had a little knob on them that were very easy to rotate. I know that CPO has variable resistors that come with their circuit kits that are the 0 to 100 ohm variable resistors. That's the part number from JAMECO, J-A-M-E-C-O. So JAMECO part number there, alligator clips, and then for each lab group, red, orange, yellow, green, blue LEDs. So get those LEDs for your groups, and these are the part numbers that I ordered from JAMECO. I hope that they're still valid. Sometimes their part numbers change. Okay, you're going to set up a circuit. I'm going to show it to you on your next slide, and you're going to dial the variable resistors until a special point when the most tiniest amount of light coming out of the LED is visible. The tiniest amount of light you can see is coming out of the LED. So you may have to do this lab in the dark or something. When they see even the tiniest bit of light out of the LED, then stop and take data. Use the voltmeter to get the voltage on the LED, and then change the LED colors. Okay, this is the circuit, but we've not plugged in the LED yet. Let's have a look. Battery, resistor A is a variable resistor, so has this little symbol on it. Resistor B is a variable resistor, has this symbol on it. We put the voltmeter in parallel with resistor B. Now, before you do anything related to photons, why don't you review with your students what you have to do to make the voltmeter more or less? For example, your students should be able to say, more RB? Well, the bigger the resistor, this is a series circuit, the bigger the resistor, it's the same current in this series circuit, same current. So if it's the same current, then the bigger resistor would have a bigger voltage drop, V equals IR. Now the voltage drop on these two has to add up to the voltage drop on the battery. So the bigger RB, the more voltage drop on RB, the higher the voltmeter reads. The bigger RA, the less the voltmeter reads. They need to be able to talk about why this is. They need to be able to talk about that, because in a moment we're going to plug in the LED, and the students need to be ready to make the voltmeter say 0, and then more and more and more and more until we see the voltage that turns on the light bulb. Okay, so here it is. Where's the LED? It's going to be in this parallel branch right here. So resistor A and battery are in a series, then a parallel resistor B, voltmeter, and the LED. You start with RA turned all the way up to its maximum resistance, and RB turned all the way down to 0. In that case, the voltmeter should read 0. Gradually increase RB until you see the LED light up. If you increase RB all the way to the point where the LED doesn't light up yet and RB is already maxed, then decrease RA, and that'll make the voltmeter go up even more until you see the LED light. Okay, so I'm going to show this to you.